What's going on, everyone? This is Fred, FindMyVapes.com. It's that time again. Today I'm going to show you how to build an OKL-T20 box mod. So last year I showed you how to build a 50 watt OKR box mod, but just like everything else, we always want more power, and the OKL might be your answer. The OKL-T20 is a very solid chip. It could deliver up to 110 watts and handle up to 20 amps. One of the most recognized box mods out in the market using the OKL-T20 chip is the Hexome V2s. And in this video I'm going to show you how to build a very similar box mod with a couple added features. Our box mod will have an on and off switch as well as reverse battery protection. And if you're interested in making this exact same box mod that I show you in this video, I do have complete DIY kits available to you. And you can get them at shop.findmyvapes.com. And if you do decide to purchase a kit from my shop, it really does help support this channel and will allow me to make more tutorials in the future. So I definitely appreciate all your support. But let's not waste any more time, let's take a look at what you'll need. So here's everything that you need to build your own OKL-T20 box mod. I will go over every item one by one and also place all of the links down below so you can get started on your project. The first thing that you need is the OKL-T20 chip. Now this is a 110 watt chip and can handle up to 20 amps. And depending on how you wire it, you can regulate the voltage between 3.5 and 5.5 volts. Next up is the enclosure. This is a custom CNC machined enclosure. Now it is machined to be similar to the Hammond's 1590G, but what's cool about this is that it's perfectly square, so it has no lean. And also, it has holes for hidden magnets. Our box mod will be powered by two 18650 batteries wired in series. So I'm using a Keystone dual 18650 battery sled. We will need a 510 connector to screw in our atomizer. So in this project, I'm using a Veritube spring-loaded 510 connector. We will need a fire switch to activate our box mod, so I'm using this black metal fire switch. In order to regulate our voltage output, we'll need a potentiometer. This is a 1K ohm potentiometer. With safety in mind, we will wire in a master on-off switch. Now this is put in place so that we can turn off the box mod and prevent it from firing. Another safety feature is reverse battery protection. And in order to accomplish that, we're going to need to wire in this PFET. Now this is put in place to prevent any damage in case you put in your batteries incorrectly. We will need two resistors for this project. The first is a 20K ohm resistor. This will be wired on the OKL chip itself. And the next one being a 1.43K ohm resistor, which will be wired in line with the potentiometer. To secure our lid to the enclosure, we're going to need some magnets. This is a 1/4 inch by 1/8 inch round magnets. You also need some grub screws so that your magnets have something to hold on to. And to wire everything up, we're going to need two different gauge wires. We have both 18 and 24 gauge copper stranded wires. You may also want to pick up some additional tools to complete the wiring of your box mod. You'll need a soldering iron, some solder flux, and epoxy. Alright, so we have everything that we need, so let's get started. So before starting any box mods, I always like to figure out the layout of my components. So here's an OKL box mod that I built a few months ago. And this layout has worked really well for me. So I'm going to do the same thing for this box mod. So what we're going to do is have the battery sled as far to the right and as far down as possible. I'm going to put the 510 connector in the center and on top. The fire switch will be on the left side, and the potentiometer will also be on the left side towards the bottom. The PFET for the reverse battery protection will also be on the left side, as well as the master on and off switch. And finally, that leaves our OKL chip, which fits perfectly on the top of the enclosure. So for this layout, we'll need to drill some holes for the 510 connector, the fire switch, and the potentiometer. We also need to make a slight modification to the corner of the battery sled, and I'll go over that in a little bit. And again, here's the completed box mod so that you can get an idea of where everything goes. Alright, so I'm back and I've drilled out all the holes for our box. So the 510 connector needs a 7/16 hole size. The fire switch needs a 1/2 inch hole size. And the potentiometer needs a 3/8 inch hole size. And I do have another video on my channel that goes over the process of how to drill your holes. So if you need more information, give that video a watch. And something extra that I did for the potentiometer hole was bevel the edges. I did this purely for aesthetic reasons because it gives you a nice silver ring around the hole. But that's entirely optional and it's not necessary. And as mentioned earlier, we'll need to make some modifications to our battery sled. The first modification that you need to do is to pop off all the contacts and cut off these tabs so it doesn't short out on your enclosure. The next modification is to make a notch on the bottom right corner of our battery sled. This is so that it could clear the screw post of our enclosure. And this is what your battery sled should look like after the modifications. As you can see, all the tabs have been cut off. And I've also made the notch in the corner. So once you're done drilling the holes for your box and made the modifications to your battery sled, we can move on to wiring the chip. Okay, so here's the OKL-T20 chip. Now I did create a wiring diagram for you guys to follow along. Don't worry about pausing the video or taking a screenshot because I did provide a link to this diagram down below. Now all of our wiring will be done on the back of the chip. This pad right here will basically be our on and off switch. This will be connected to our master on-off switch as well as the fire switch. Here's our negative sense pad, and this will be connected to our ground on the chip. This is our positive sense pad, which will be connected to the voltage out of the chip. The next pad is our trim, and this will be connected to the potentiometer, which will allow us to regulate our voltage. Again, here's our voltage out pad, which will also be connected to the positive pin of our 510 connector. And again, here's our ground pad, which will also be connected to the negative contact of our battery sled. And finally, here's our voltage in pad. This will be connected to the positive contact of our battery sled. But first, it's going to go through our PFET to provide reverse battery protection. And we will need a 20k ohm resistor to connect the on and off pad with the voltage in pad. Alright, so what I always like to do first is to tin the pads that we'll be using. So go ahead and use your flux and tin all the pads that we'll be using with some solder. So if you look at the wiring diagram, we're going to need to connect a 20k ohm resistor to the on and off pad and the voltage in pad. So what I like to do is cut the resistor to size, then solder it to each pad. And again, I like to tin every single solder connection. Once you have your resistor prepared, you could go ahead and make your connection. So next we could connect our fire switch wire to the on and off pad. Now since this wire does not carry a high amp load, we could go ahead and use 24 gauge wire. And just like all of our wiring, we want to strip and tin the wires prior to soldering. And if you're not familiar with using flux or tinning wires, I do have a video that's dedicated to that subject. So go ahead and check out that video if you want more information. And for this wire, you just want to make sure that it's long enough to reach your on and off switch. We're now going to move on to the sense pins. If you look at the wiring diagram, you're going to see that the negative sense pin connects to the ground and the positive sense pin connects to the voltage out. We can now move on to the trim connection. This will be connected to our potentiometer. Now again, this is not carrying a high amp load, so we could go ahead and use 24 gauge wire. The next few connections will be carrying an amp load, so we want to use a thicker gauge wire. In my case, I'm using 18 gauge wire. The first one being the voltage out wire, which will be connected to the positive pin of our 510 connector. The next one is the ground wire, which will connect to the negative contact of our battery sled. And finally, we have the voltage in wire. This is how we're going to power the unit with our batteries. Okay, so the OKL chip is fully wired now, but you may notice that I made a small mistake on my very first wire. I want all of my wires being routed in the same direction out this end. But on the first wire, I didn't do that. Now I can easily just bend the wire so that it's facing the same direction, but I like to have clean wire management. So what I'm going to do is unsolder this wire and reconnect it so that everything's facing the same direction. So now we have all the wires soldered correctly, and as you can see, everything looks nice and clean. What I would recommend doing is heat shrinking the chip, but before doing that, you may want to label all the wires. So I went ahead and used some heat shrink to protect the OKL chip. Now I used some 3/4 inch clear heat shrink, and I also labeled the wires so I know which is which. So next we're going to work on the potentiometer. If you look at the wiring diagram, you're going to see that we need to connect the middle leg to the outer right leg. Then we need to connect a 24 gauge wire to that leg. That wire will eventually connect to the ground wire of our 510 connector. And on the outer left leg, we're going to solder in our 1.43k ohm resistor. From there, that resistor will connect to the red trim wire from our OKL chip. So after soldering both the two legs, what I like to do is bend the wire and the resistor straight back up. And then I can go ahead and heat shrink these two connections just to give it a little bit of protection. Now the reason why I want to bend it up, because that's the orientation of the potentiometer. If you look at the face of the potentiometer, this is the top. So when you put it into your enclosure, you want the wires going up. And before connecting your trim wire to your potentiometer, you want to get a good idea of how much wire you actually need. So I have my components laid out inside the enclosure so I know how much wire I need to cut off. Also, before soldering, don't forget to slide your heat shrink onto your wire. So let's take a look at our PFET. The PFET will have 3 legs. We have a gate, a drain, and a source. The gate will need a negative wire that's connected to our ground of our 510 connector. The drain will have a positive wire that's connected to our positive contact of our battery sled. And the source will be connected to our voltage in wire from our OKL chip. So go ahead and wire these up. You'll want to use 18 gauge wire for all these connections. And again, do a test fit so you know how much wire you need for the voltage in. So we have 3 more wires left on the OKL chip. We have the on and off wire, the voltage out wire, and the ground wire. So we're going to move on to the on and off switch. The master on and off switch has 3 legs, but we only need 2 of them. We need the middle leg and one of the outer legs. The middle leg will connect to the on and off wire from our OKL chip, and the outer leg will need another 24 gauge wire which will eventually connect to our fire switch. What I like to do is cut down the legs to make it a little bit more compact. Again, measure out how much wire you need before soldering, and don't forget the heat shrink. Let's take a break from the OKL chip and move on to the battery sled. So if you take a look at our wiring diagram, you'll see that our battery sled is wired in series. So we need to bridge the bottom contacts with some 18 gauge wire. Next, on the top negative contact, we have 2 wires connected to it. One of those wires is the ground from our OKL chip, and the other wire needs to connect to the ground of our 510 connector. And on the top positive contact, we need to solder the drain wire from our PFET. So we're pretty close to being done. We just have a few more wires to hook up. We have the fire switch wire, we have all the negative wires that will connect to the ground of our 510 connector, and we have the voltage out wire which will connect to the positive pin of our 510 connector. But before doing all of that, I want to go ahead and epoxy our potentiometer to our enclosure. And the best way to do your potentiometer is to place it inside the hole, then cover it with electrical tape. Once it's all taped up, you can spread epoxy over the tape. So I have my potentiometer all taped up, and you really want to make sure you do a good job here. You do not want any epoxy seeping into the potentiometer because that could ruin it. Alright, I'm back and I have carefully epoxied my potentiometer onto my enclosure. I also took this time to epoxy the battery sled as well as the magnets on my lid. So we can now move on to the final steps of our box mod, starting with the fire switch. If you look at the wiring diagram, you'll see that there's 2 pins that we need to connect to. One of those wires is coming from the master on and off switch, and the other wire is the negative wire that connects to the ground of our 510 connector. What I like to do is first install the fire switch onto our enclosure, but leaving it loose so there's room for adjustment. Then you can connect your wires, one from the master on and off switch, and another 24 gauge wire for the ground. So now we can move on to our ground wire. Now this part can be a little bit challenging because there's so many wires, but we have the ground of our fire switch, the ground of our PFET, the ground from our potentiometer, as well as the ground from our OKL chip. And what I like to do first is to twist all the wires together in a bundle, then tin them. Then you could create a pool of solder on the ground ring of our 510 connector. Then connect all the wires to that ring. And now we can finally install the voltage out wire to the positive pin of our 510 connector. And once you do that, you should now have a working spring-loaded 510 connector. If you need more detailed instructions on how to install a spring-loaded 510 connector, check out another video on my channel for the full how-to. And after all of that, you are basically done. Just make sure you tighten up the nut for the fire switch, route all the wires as cleanly as possible, and you may also want to epoxy the on and off switch to the side of the enclosure. And that's pretty much it. Just remember that the battery sled is wired in series, so it goes negative, positive, negative, positive. The only thing left to do is to put some batteries in here and make sure all of our hard work has paid off. Oh yeah. If you've reached this point in the video, hopefully that means you're ready to build your own box mod. I've been using the OKL-T20 chip for the past few months and I've had absolutely no issues. It really is an enjoyable vape. And I know that when you finish your box mod, you're gonna love it as much as I do. And like I mentioned in the beginning of the video, if you want to build this same exact box mod that I showed you in this video, you can get the complete kit at shop.findmyvapes.com. That's all I got for you today. Thanks for watching, and I'll see you on the next one.